All right, welcome to our lesson. Here we're going to be talking about angles in degrees and radians. Now the main ideas that we're going to cover are converting between angles that are in degrees and angles that are in radians. And then secondly, what we're going to be doing is we're going to be graphing both of these in what we call standard position, both in degrees and radians. You may want to have a calculator handy for this lesson. I'm going to be doing all my examples without one. So that is your option if you wish to use one. So to get started, the key thing to note is that when we talk about angles, we're talking about rotation. And from what you can probably remember, one rotation equals 360 degrees. You go a full circle, you've turned a full 360, same idea. But now with radians, now we have to add in this third idea that one rotation equals 360 degrees equals 2 pi. You go a full turn and you've turned 2 pi radians. The idea is that if this were a circle with a radius of 1, 2 pi would be the distance you travel all the way around. And this is where we get radians from. If you want, look at one of the attached image files and it shows you in a very nice, very concise way how we come up with 2 pi radians within one rotation. So, keeping this in mind, we want to convert the angle 60 degrees into radians. And this is basically a conversion. So what we do is we take 60 degrees and we multiply by a conversion factor. In this case, we want to get rid of degrees. So we're going to put 360 degrees on the bottom and an equivalent on top. Well, 360 represents a full rotation, so a full rotation in radians is 2 pi. Now, since I'm doing this without a calculator, I need to do as much simplification as I can. So, well, I can cancel 60 out of this and 360, leaving 1 and 6. So if I rewrite this, I have 1 times 2 pi over 6. And I can cancel a 2 out of both of those, leaving a 1 and a 3. So that leaves me with pi over 3 radians as my answer. There's no symbol for radians like there is for degrees, so when you say pi over 3 radians, if you don't put a degree marker, it's just assumed that you're talking about radians. So in this example, here we have negative 315. Again, we're in degrees, so we multiply by the conversion factor that gets rid of degrees. So 360 degrees on the bottom and 2 pi radians on the top. So what can we cancel? Well, we can cancel a 3 out of both of these, leaving 120 and leaving 105, negative 105 that is. So I have negative 105, 2 pi over 120. What else can I cancel? Well, I can cancel a 5 out of this, and I can cancel a 5 out of that. So that will leave 24, and that will leave 21, negative 21. So negative 21 times 2 pi over 24. So I'll cancel 2 out of both of these, leaving 12 and 1. So I have negative 21 pi over 12. Can I simplify that some more? Yes, I can. I can cancel another 3, leaving 7 and 4. So I have negative 7 pi over 4. Again, no need to say radians because I'm not using a degree symbol. And so the default is there's no degree symbol, you're talking about radians here. So now we have an angle in radians. And we want to convert this into degrees. So now we want 2 pi on the bottom because we want radians to be gone, and we want to end with 360 degrees. So what can we cancel? Well, the pi's can cancel, and usually you will have a pi in your answer, but not always. A lot of people make the assumption that there has to be a pi to make it a radian. No. If there's no degree symbol, it's in radians, whether there's a pi or not. So the pi's cancel. All right, I can cancel this 12 with this, leaving 30. So let me rewrite that. 5 times 30 degrees over 2. And I can cancel 30 and 2, so that's 15 and 1. So 5 times 15 degrees, and that will equal 75 degrees. Again, I put the degree symbol so we understand that we're talking about degrees here. The next one, negative 7 pi over 3. Again, we are going to multiply by that conversion factor. 2 pi radians is on the bottom because we want that to go away, and 360 on top because that's what we want. So what can we cancel? Again, the pi's cancel. The 3 cancels here, so I have 120 degrees. So negative 7 times 120 over 2. So I can cancel a 2. And so we have negative 7 times 60 degrees, which is negative 420 degrees. Now, had you done this with a calculator, what you would want to do is not include the pi. You would multiply negative 7/3 times 360 over 2. And what that would give you is that would give you 420. Pi is an irrational number, so when you include it, you're going to have a long decimal string at the end. So when you do these conversions, my suggestion is to leave pi out. Now here, you're going to see a lot of common angles that it's good for you to keep an eye on and to try and memorize. Because if you can memorize them, it's very helpful when converting back and forth from degrees and radians. So, what I have here is I have this chart. And these are all angles in degrees, and we want the corresponding idea of the angle in radians. Now, instead of doing the conversion like we did before, let's think about this a different way. What's the relationship between 360 and 180? Well, 180 is half of 360. The same should be true here. This should be half of 2 pi. So what's half of that? Well, that would be pi. So, if we ask again, what's the relationship between 90 degrees and 180? Well, that's half of 180. So, pi, if I take half of that, we can write it as 1/2 pi, or pi over 2. What I want you to do is pause the video right now and see if you can fill out these other 3 angles. And then I'll come back and then I'll show you what the answers are. Okay, let's fill it in. So 60 degrees, well, it's not a multiple of 90, but it's a third of 180. So it's 1/3 pi, or pi over 3. 45, well, that's half of 90. 90 is a half to begin with, so we're going to divide that by 2. So that's 1/4 pi, or pi over 4. And then finally, 30 degrees, well, that's half of 60. So if I take half of a third, that's 1/6 pi, or pi over 6. These are some very common angles that you will see. Now, down here, we have another chart. Now, using the angles that we had above, those are basic building blocks that allow us to fill in all of these other angles. So let's see, 120, well, that's twice as big as 60, and 60 is 1/3, or pi over 3. So that's going to be twice as big. So that's going to be 2 pi over 3. 135, well, I can take 90 and 45 and add them together. So that's a half plus a fourth. So that's 3/4 pi, or 3 pi over 4. What I'd like you to do, pause the video again, look back at the chart that we just filled out and see if you can't come up with all the different angles here using the above angles as building blocks. Okay, let's see how you did. Well, 150, well, we could take 30 and just multiply that by 5. So that's 5 pi over 6. With 210, same thing. We can take 30 degrees and multiply it by 7. So in the similar way, this is 7 pi over 6. 225, well, that's 45 how many times? 5 times. So that's 5 pi over 4. 240, well, I can take 60 times 4. So that's 4 pi over 3. 270, well, that's 90 3 times, which will be 3 pi over 2. 300, that's 30 degrees 10 times. So that would be 10 pi over 6. Whoops, let's simplify that. So that would be 5 pi over 3. 315, that would be 45 degrees 7 times. So we're going to take 7 times pi over 4. And then finally 330, that's 30 degrees 11 times. So that's 11 pi over 6. These are all the common angles that you will see in trigonometry between 0 and 360, or in radians, 0 and 2 pi. And it's important that you see this. And it's also important that you make these connections down below. What I'd like you to do is I'd like you to look back at these angles up here. Rewind the video if you have to. Look at this chart and this chart. And then I want you to make notice of the different denominators and look at what their angles in degrees are factors of. So pause the video and try to fill this in, and then we'll come back and we'll go over it. Okay, let's see how we did. Denominator of 2, well, we had pi over 2, which was 90, and 3 pi over 2, that was 270. Those are degree multiples of 90. Angles in radians with a denominator of 3, those are degree multiples of 60. Angles in radians with a denominator of 4, those are degree multiples of 45. And then finally, angles in radians with a denominator of 6 are degree multiples of 30. And that should make sense because pi over 6 is 30 degrees. Pi over 4 is 45. Pi over 3 is 60, and pi over 2 is 90. So if you can see those denominators, that helps to clue you in that this is a multiple of this angle. All right. Now the second thing we're going to look at is drawing angles in standard form. And this is what standard form looks like. It uses the x and the y axis. All angles start at the initial side on the positive x-axis, and then they rotate, that's what angles are, out this way until they stop at their terminal side. And so every angle that we draw is now going to be drawn on the x-axis, and they always start from right here. So we want to draw an angle in standard position given that it's 280 degrees. Well, we'll start with our initial. Now notice that I don't label the x and y axes. It's better that we try and remember what these axes mean. So this would be 90 degrees. Okay, well, 280's got to be bigger than that. This is 180. Well, it's got to be bigger than that. Down here, this is 270. Well, it's real close to that, but it has to be just past it. So this right here is 280 degrees in standard form. The next one, 710. Well, a full circle is 360, so this is going way past 360. So what's going on here? Well, one rotation is 360 degrees. What would be two rotations? Well, just double it, and you would get 720. Well, this is almost that, but just short. So what's happening with this angle is we're going around once, that's 360, and we're going around almost to 720 and stopping just short. And so this is 710 degrees. So angles can be bigger than 360. It can go past a full rotation. And this is why we draw our little spiral, our arc, to tell us how many times we're rotating. Negative angles are also possible. When we have a negative angle, we still start on the positive x-axis. However, a positive angle is going to rotate up this way. So a negative angle is just going to rotate in the opposite direction. It's going to rotate down. So let's see. This will be negative 90, negative 180, negative 270, negative 360. Got to keep going. Negative 450 is right there. Okay. So let's do this again. Negative 90, negative 180, negative 270, negative 360, negative 450 is right here. Oh, let's just back it up a little bit. There we go. So this is negative 440 degrees. Again, we use the axes as helpers to figure out where we have to stop. And again, each axis is 90 degrees apart, except in this case, since we're going down, it's negative 90 as I counted. Now we have an angle in radians, 2 pi over 3. Now there's two ways to look at this. One way is to say, all right, well, we start at 0. A full rotation is 2 pi. A half rotation is pi. A quarter rotation is pi over 2. So that means, well, if I look at the numbers attached to pi, that's 2/3. And 2/3 is between 1/2, that's what's attached to pi here, and 1. So that means my angle is somewhere in here. However, another way to look at it is to say, wait a minute, what's its denominator? 3. So it's a multiple of 60. And if you look at the top, well, it's 60 times 2. So that's going to be 120. And when we graph angles, we usually tend to think in degrees more than radians. We're more comfortable with degrees. So if you can make a quick conversion in your head, that's going to help you graph them a whole lot faster. 11 pi over 6. Okay, well, if we look at our denominator, that's a 6. So that means this is a multiple of 30. Which multiple? Well, 30 times 11. So that's 330 degrees is where this is. So that's going to be over in this quadrant here. 11 pi over 6. Negative 9 pi over 4. Well, again, 4 is our denominator, so that means it's a multiple of 45. So if we multiply 45 by negative 9, well, that's going to be just a bit more than a full rotation, but it's going backwards. So it's going to go down. So I would need 8 of these 8 45-degree angles to make a full rotation, but I've got one more to go. And so that should be negative 405 is negative 9 pi over 4. So we'll stop this video and give you a chance to work on the worksheet, and then we'll come back and we'll see how you did.